Hey guys, hope you're having an awesome day. In the previous video, we did the Hello World program. So let me just bring up EXERCISM over here. Yep, so this is the one that we did last time. So let's do another easy program for this time. So this time we're going to be doing the Isogram program, which I have another tab open here. So I'm going to put the introduction on your screen right now. But just to summarize, an isogram is a word or phrase without a repeating letter. However, in this case, we're allowed to use spaces and hyphens, like they're allowed to be repeated multiple times. So a couple of examples of isogram they're given over here. It's lumberjacks, background, downstream. Basically what's happening here is you can see that no letter is being repeated. So over here in lumberjacks, no letter is being repeated. Each letter is being used just once. However, isograms over here is not an isogram because, as you can see, the S is repeating 2 times. So isograms is not an isogram, but all these letters where only one letter is occurring at a time in a word, that is an isogram. So today we're going to be writing this program in Golang. So let's get into this. First, we'll have to download this project from EXERCISM. So we can just copy this over here and minimize this over here. Then we could go to a terminal, see here, and we can run this directly. There you go. Now we have Isogram EXERCISM project inside our folder. So over here we can see, there you go, isograms over here. We can probably get rid of hello world, this, and this, and we can open our Isogram project. So it looks like EXERCISM did not give us anything over here. Like there's no function over here to start from. Like before in hello world, they gave us a function to go off of, which was the hello world function. But over here you can see that EXERCISM didn't give us a function to start things off with. This is pretty standard for EXERCISM, and they do it all the time. So the test cases in this project are going to be looking for specific function names. So we can't just use any function name over here. So we have to figure out what EXERCISM actually wants from us. There are a couple of ways of going about it. You can go into isogram test and actually start looking. So yeah, over here you can see that it's looking for the isIsogram function so that it can send stuff to. But suppose you don't want to go through the isogram test file because you're fancy that way. You can just go over here, write a normal, any function with any name. So over here we could do function example, and yeah, that we can just start off with this. So we can also test this using the neat command that isogram gives us. So go test v benjamin. So we can minimize this, run it over here. No test file. Oh, we didn't go to our isogram folder. So there you go. Now it should be fine. There you go. So over here, the test cases, while we're running, you can see that it's looking for an isIsogram function. So you can basically get it from here. It's saying undefined isIsogram. So the test case is trying to call isIsogram and it just can't find it because there is no isIsogram function. There's just this example function. So we can just take this function name over here and put it over here. Great, so now we have our function name. But the thing is, the test case is also looking for a return. So in the hello world, you can see that we were returning a string, and over here we were returning this. So the same thing's going to happen with the isIsogram function. So we can again go back to isogram test and actually look what it expects, or we can just stay here and do this. Let's just return any random thing, random string, and let's see what it complains about. So we can just run this again. There you go. So we can see over here, it has too many arguments and call to is isogram. Okay, so the thing is isogram inside test is sending a string, but we're not accepting anything over here. So as you can see over here, this function is not accepting anything. So it probably wants to give us a string so that we can actually see if that string is an isogram or not. So we can just make a variable over here, a string type. So that should satisfy that condition. So there you go. Now we should be able to accept strings from the test file. So now this won't show up. Just to show you what's going on here, isogram.test.go, which is our test file over here, is calling is isogram, and it is sending a string. So have string is basically what the isogram test file is trying to send to is isogram. But yeah, is isogram function doesn't want that. It just wants nothing. It doesn't want to accept anything, which was our previous case over here, because earlier this was just like this. So it wasn't willing to accept any variables, arguments, and such. So there you go. We can save this back. So this is what that means over here. And then this is probably nothing over here. Too many arguments to call. Okay, so it's the same thing. So we can probably run this again. We won't have the same error because now we're accepting a string. Oh, we have this. I guess I missed this. So invalid operation, expected mismatch, type, string, and bool. So over here we're returning a string, but it looks like isogram test.go wants to compare a bool. Okay, so just going off of this, it probably wants a true or false to the string that it supplies to us. So if it gives us a string, it wants a true or false to say true if it's an isogram and false if it's not an isogram. So what we can do is we can just turn this into bool and return true here, true. There you go. Now if we run this again, there you go. So what is happening over here? So right now, okay, now it's actually testing the logic. So over here we got word, which is an isogram, so it passed because we were always sending true, but it failed on 11 because E is repeating, but we sent true to it. We hard coded true into it and it wanted false. So we can actually start writing our program now. So first what we can do is we can make a cache like this. So what the cache is going to do is whenever we go through each letter of the string, we can just put stuff over here in the cache to make sure, okay, this letter has occurred before. As we go along, I can explain better. So just watch till the end of the video. Now we'll go through each letter in the string and see if it occurs. If it occurs, then we're just going to put it in our cache. Okay, so now we're going to go through each letter in the string and just add it to cache as we see it. If it repeats, so if we find a letter that's not in the cache, then we're just gonna put it over there. But if it is in the cache, then it's not an isogram because it repeated, because there was a letter before that was added to cache. So how we can go about it is we can just loop through our iso string. So take the val range iso. There you go. Now we can loop through each character inside this iso string. So let me just explain what's happening over here. So this is a really common way of looping through a string. So for each value in the range of iso, we're just gonna go through each character. So while writing this for loop, you can see we have this underscore. So what happens over here is this first value is gonna be an index. So suppose the string has 5 letters in it. So as we go through the for loop, it's gonna give us 0, 1, 2, 3, and 4. but val over here is actually going to give us the value. So each character that's inside the 5 letter string, we're actually going to get the letters if we write it like this. And range ISO is basically saying that we want to go through all the letters that are inside ISO one by one. So there you go. Now we're inside the for loop, and what's happening, and we're just going through each letter in the string. So now we can just go through each letter and just put in the cache if it has not been previously put in the cache, and just exit out and say that it's not an isogram if it repeats in the cache. So what we can do is we do first have to take care of the spaces and the dashes. So let's take care of that. If, oops, there you go. If string, so there you go. Now we have this character over here. If it is equal to, oops, a dash, or string is equal to this, then we just want to continue because we are ignoring those. So let me just go through what's happening here. So we're taking each value, each letter from the ISO string, and if we have a dash or a space in it, we're just going to ignore them because they're allowed to repeat themselves. So this is what this says. If the letter is a dash or a space, then we're just going to continue. We're not going to do anything to them. We're not going to put in the cache. We're not going to do anything to them. But what if there are not dashes or spaces? Then we can do else if strings.contains cache and string val, then return a false. So what's happening over here is, oh, I did not import strings. So let me just import strings, then I can explain what's happening here. There you go. So now if we find a letter that is in the cache, so what happens is, suppose we have an example like this, isograms. So what's happening here is, in this loop, we're going through each letter like this. So first it's going to be I, S, O, G, R, A, and so on. So if I is not in the cache, then we want to put it in the cache. But if I is in the cache, then we say that this word is not an isogram. So for example, I is not repeating over here, so I is going to go inside the cache, then S is going to go inside the cache, and then as we go along, once we come here, we can see that S repeated itself because S over here, this S over here is already going to be in the cache. So we can just exit out of here and say that, okay, this is not an isogram because this S was in the cache and we cannot let letters repeat themselves. So this is what this is doing over here. Once we see a S repeat itself, we're just gonna get out of here. And this is not just for S, this is for any val that comes out of here, out of the ISO. So now we actually have to put stuff in our cache. So what if the letter was not in the cache? Then we can just do this. So if the letter was not in the cache, we're just going to put it inside the cache over here. And then this thing will just keep looping itself until one of these cases, until this false is satisfied. If this false is not satisfied, then it's just going to return a true over here. So if it finds a letter that did repeat itself, it's just going to exit out of it immediately. We don't have to go through the entire string. We can just exit out immediately and return a false. We don't have to go to the end of the string, because even if we do, we still know that the letter repeated somewhere in the middle of the string, so we can just exit out of there. But if we go through the entire string, so if this is not reached, then this for loop will run for the entire ISO string. So it wasn't able to find anything that was in the cache, So then we can just return a true. So the true will say that this is an isogram. So you can just do it is an isogram. And over here, we can just write a comment, not an isogram. Just exit out from the middle of the string. There you go. Cool. So now we have this written up. Now we can run this. Okay. So, it looks like a couple of them passed, but one of them failed. So, word with duplicated character in mixed case. So, word alphabet expected false got true. Okay, so this was a capital A. So once this went inside the cache, technically once our program reached this part, it should have exited with a false, but it exited with a true. So over here, we have to take care of the mixed cases. So the mixed case basically means the capital and the small letters. We have to take care of those. So one way that we can go about it is we can turn everything to capital. So we can turn this into capital, basically all the letters beside this A to be capitalized. And what will happen is, since capital A will be capitalized, it will see that capital A was already in the cache in our program and just exit out with a false. Or we can do the same thing but just make everything lowercase. So we can either turn this into uppercase or lowercase and go about it like that. So in this example, let's turn everything into lowercase. So this is our string. We're going to turn everything to lowercase. So strings dot to lower. So yeah, strings that we imported, we're going to use the to lower function inside it. And what this does is it takes whatever string you give it. So over here, we're giving it the ISO string, and it will turn everything into lowercase. I would recommend just remembering strings and the to lower function and the contains functions, because you may use them a lot. I know I use them a lot. So over here, yep, we're turning the ISO string to everything to lowercase. And over here, I didn't explain this one. So in this case, what's happening is we're looking inside cache. So cache is over here, and we're seeing if this letter, so string val, if this letter is inside the cache. Also, I've turned everything into string because otherwise they're just going to be bytes. So we have to convert the bytes to string. That's why I'm putting string everywhere over here. So I can just give you an example like this. FMT. For now, let's just get rid of this. And we can just print each letter. So fmt.println. This is the letter in the string. And then if I just use val directly, you can see that this happens. So over here in subdir, oh, this is a really complicated word. So it's taking each letter inside it. Oh wait, it's not. Yeah, sorry. This one's for alphabet. So over here, as it's going through alphabet, it's just using its byte version instead of the actual letter. So if I turn this into string over here, then it will put out the actual letters. So there you go. Because we're using string instead of the actual val, because the val is a byte, since we're using string, we're converting it. So we're converting the letters to characters basically. So over here you can see, okay, now we can actually see the alphabets. That's why I've been using string everywhere over here. So let's just get rid of this. We don't need this. We also don't need this. And let's now try to use this. So now we're converting all the letters inside our string to lowercase so that we can just compare lowercases and not have to deal with mixed case letters just giving us incorrect results. So let's get rid of this. There you go. Now all of our test cases are passing over here. So you can see that it passed because, yep, nothing failed over here. And yep, everything passed. There are no failures. So awesome. We wrote the Isogram program. Now what we can do is we can just upload this to EXERCISM. So we can go back here, go to EXERCISM, and we can just submit our EXERCISM code that we just wrote using the EXERCISM submit command. So we can just take this, let me just minimize this, EXERCISM submit, and the isogram.go file, which is this file that we were writing the code in. And we can just upload this to EXERCISM. There you go. So we uploaded our code to EXERCISM, which is awesome. If you actually want to see this solution that we wrote, we can just copy this URL that they gave us over here, open Isogram, over here again, another tab. There you go. Now we can see our code over here. I encourage you to really join EXERCISM and join the ops guy team and just upload your code as well. I'll be more than happy to review them and give feedback, and other people can give feedback too, which I feel is a really awesome thing. So that's it for today's video. Hope you enjoyed it. Hope you learned something from this. We wrote the Isogram program today. If you like the content, make sure to like and subscribe. It really helps the channel out a lot. And yeah, I'll see you next time. Have a good one. Bye.